Right, so we have converted from binary to denary, or decimal numbers, the same thing. Let's have a look at how to convert the other way around, so from decimal numbers to binary numbers. So we're going to convert the number 75, and the way I would go about this is I would write the place values for binary starting at 1, then we write 2 because we're multiplying by 2 each place value. So the next one is 4, 8, 16, 32, 64, and 128, like this. So I'm writing 8 place values up to 128. Now, if I wanted to convert the number 75, I would look at the largest value here, which is 128. And I would see that 128 is actually bigger than 75. So I would put a 0 underneath that value. So I don't need 128. 64 is smaller than 75. So I would put a 1 underneath that. And then if I subtract 64 from 75, I would end up with 11. So now I have 11 to represent with the rest of the place values for binary. 32 is bigger than 11, so I don't need 32. Same for 16, it's too large. The number 8 is not larger than 11. It can in fact represent part of it, so then I would put a 1 underneath that. So then 11 minus 8 gives me the number 3, like so. 4 is too large to represent 3, so we're going to put a 0 underneath that. 2 can represent part of 3, so we're going to put a 1 underneath that. And we are left with representing 1, which we can just do so with the last value here. And 1 minus 1 gives us 0, like this. So this would represent the number 75, because 64 plus 8 plus 2 plus 1 give us the number 75, like this. Now the one other thing to mention here is this value right here, the rightmost value in binary, is called the least significant bit. This is very important because if this value is a 1, then we know the result of the conversion is going to be an odd number. So if you are asked a question like, how would you know if a binary number is even or odd without converting it? You would say, if the least significant bit is a 1, then the result of the conversion would obviously be an odd number, because we're adding 1 to the final number, which would put it into odd. If this number is 0, so if I convert it to a 0 now, then the result would be 74, which would be an even number, like so. The one on the other side, on the far left side, this is called the most significant bit. So this is the highest value in your binary number. And if you have a binary number with 4 bits, like so, so if we do its place values like this, 1, 2, 4, and 8, then position 8 would be your most significant bit, and this position will always remain the least significant bit. So the most significant bit changes depending how long your binary number is, whereas the least significant bit always remains the same because it's always that first position with the smallest value in its place values. And if you haven't figured out already, when we mention this term bit, we are talking about simply either 1 0 or 1 1, like this. So this is a 4-bit number, and this up here is an 8-bit number because it uses 8 zeros or ones. It doesn't matter if this one here was to be changed to a 0, this is still an 8-bit number.